Okay, the first thing I want you to look at is on your module page in Canvas. I gave you a link to the sieve here, and it really explains the concepts in this chapter extremely well. I'm not going to ask you that on a test, but it shows you what prime means, it shows you what composite means, it shows you how all the different factors lay out, and it's a really useful tool. So I implore you, I beg of you, to please try to watch that video. And again, it's linked in your Canvas module right above where you saw this lesson. Okay, so the first thing I want to talk about are definition type things, and the first one is divides. Okay? Of course, we know what divides means, but the way they explain it here is I know that 14 divided by 2 is 7. That means that 2 divides 14 evenly. So that's what they're saying by that. Now, I also know that 2 times 7, let me fix that, sorry. 2 times 7 equals 14 if I flip it around like a fact family. 2 and 7 are therefore called factors of 14 because they make up the 14. 2 in this case is called a divisor because it divides 14 evenly. And then 14 is called a multiple. But if I start with 2 and I list off all the multiples of 2. 2 times 1, 2, sorry, I'm having trouble with the pen today, sorry. 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6, 2 times 7, and it keeps going. These are the list of multiples of 2, and so 14 could be called a multiple of 2. And so that just gives you, that's not probably anything I'm going to ask you to do out so much. I might ask you factor, but I think I asked you that earlier in the semester already. But that just tells you what this section is going to be about. Now if I look at this next one, 14 divided by 3, that doesn't go evenly. So if we did try to do it old school, I get a remainder of 2. So in this case, we'd say that 3 does not divide 14, and that's just the language they use here. The next thing we have is even and odd. Even means it's divisible by 2. Odd means that it's not divisible by 2. So if it ends with a 0 or a 2 or a 4 or a 6 or an 8, that means it is divisible by 2. If it ends with a 1, 3, 5, 7, or 9, that means it's not divisible by 2. That means it's odd. So all of these are called my odd numbers, and all of these are called my even numbers. And it doesn't matter what the preceding numbers look like. It's all based upon the end. So if the number ends with one of these, it's even. If it ends with one of these, it's odd. Okay, the next thing they talk about is prime and composite, and again that video I linked earlier in the module will help you with that. But prime means it only has factors of 1 in itself. Okay, for example, 7 is a prime number, and the reason that 7 is a prime number is the only two things that make up 7 are 1 times 7, so that would make it prime. Composite means it has other numbers other than 1 in itself. For example, the number 9, let me write this for a second, put that in your notes. The number 9 is called a composite number. Because 9 does, of course, have factors of 1 times 9, just like every number in the whole universe. But 9 also has other factors. For example, 3 times 3 is 9. So since 9 has a divisor other than 1 and 9, it is called composite. Now, I'm not going to trick you with it, but one of those facts that clutter up your mind sometimes. 1 is neither prime nor composite. It's a special case and it's called a unit. And that's not something I'm going to ask you, but you might have a challenging student, a really bright student later on that quizzes you on something like that. So just know that there's one little catch there. 1 is neither prime nor composite. All the rest of the numbers are one or the other. Okay, so the next thing we have is a factor tree, and you're going to use a factor tree a lot in this section. So I'm going to break 180 down into its factors. Now, whatever factors you choose for 180 are going to be fine. You're just going to work it all the way down. Some of you might choose 2 and 90. Some of you might choose 60 and 3. However you get to the bottom of the factor tree, it's your call. Okay, you can use whatever factors that go into 180 that you want. Okay, I'm going to use, let's say I'm going to use 20 times 9. Okay, 20 times 9 is 180, so that's what I chose to use. But like I said, you could use whatever numbers you wanted. So if I break down 20, I can break down 20 into whatever factors that go into it. I'm going to choose 4 and 5. And what I notice about 5 is a prime. So as soon as you get a prime number, you want to circle it. Okay, 4 is not prime, and the reason 4 is not prime is that it's 2 times 2. But 2 is prime, and 2 is prime, so I can stop there. Then we go to the other wing of the factor tree. 9 breaks down into 3 times 3. Those are both primes. So this factor group would be 2 times 2 times 3 times 3 times 5. And if you multiplied all those together, 2 times 2 is 4, 3 times 3 is 9, and 5. Okay, so 4 times 9 is 36, and 36 times 5 would be 180. So I didn't leave anything out. That is the factorization. So you can always check these by multiplying them back out. So what you see here, 2 times 2 times 3 times 3 times 5, that is the proper factor tree there. Your factor tree might look a little different in the body of the factor tree, but the answer there for primes is going to be exactly the same regardless of which factor group you used. Now the way you want to write your answer is you don't write it all listed out. You're going to write it with exponents. So see, there are 2 2's, so 1, 2. And there are 2 3's, so that's 3 to the 2. And then you have a 5. Okay, so that's how that one would look. And this would be the prime factorization of 180. And we'll do a few more of these as the lesson progresses. The next thing we have is divisibility test, and this is probably a good time to do a break of the video.